So let's solve this problem. So given the circuit diagram and observe that there are two voltage sources, the 15 volts and the 12 volts, then we have these six resistors. Then to find the total current passed to any part of the circuit, so using this Kirchhoff's law, so to find out the flow of the current, since the current from high potential to the low potential, so therefore from this junction, this is current 1, from this junction, this is current 2, and from this junction, since this is current 1, current 2, so therefore this current is current 1 minus current 2. Then from this junction, this is current 3. So therefore this current, so we have current 2 and current 3. So this is current 2 minus current 3. Then since this current is also equal to current 3, and this current is also equal to current 2, then to find out the different equations, so from the first loop, so observe the movement of the loop is clockwise. So therefore, if the flow of the current is clockwise, so that one is positive, and for the flow of the current is counterclockwise, then that one is negative. So from the first loop, so there is the voltage, so this is 15 equals, so for current 1, since this one is clockwise, so this one is positive, so just multiply these two, so this is 3 times current 1. Then for this current, since this one is also clockwise, so this one is also positive, so multiply these two. So this is positive 5 times current 1 minus current 2. Then to simplify, so distribute this 5. So this is 5 times current 1. And we have this negative 5 times current 2. Then combine like terms. So this is 8 times current 1 minus 5 times current 2. So this is now our first equation. Then from the second loop, so again, the movement of the loop is clockwise. So for this current, since clockwise, so this one is positive, and since on this loop, there is no voltage, therefore this is 0 equals, so this is positive, so this is 5 times current 2. Then for this current, since clockwise, so positive, and multiply these two, so positive 4 times current 2 minus current 3. And also for this current, since this one is clockwise, so also positive, so multiply, so plus 4 times current 2. Then since this current is counterclockwise, therefore this one is negative, and multiply these two, so negative 5 times current 1 minus current 2. Then to simplify, so distribute this 4. This one is 4 times current 2. Then this becomes negative 4 times current 3. Then plus 4 times current 2. Negative 5 times current 1. Negative times negative, that's positive 5 times current 2. Then combine like terms and arrange. So starts with the current 1. So we have negative 5 times current 1. Then for current 2, so we have 5 plus 4, that's 9, plus 4, that's 13, and plus 5, that's 18. So this is positive 18 times current 2. Then we have negative 4 times current 3. So this is for equation number 2. Then from the third loop, so again, the movement of the loop is clockwise. Since there is a voltage in the third loop, so this is 12, then equals for this current, so this is clockwise, so positive, multiply, so 6 times current 3. Then since this one is counterclockwise, so this one is negative, so multiply, so this is negative 4 times current 2 minus current 3. Then to simplify, so this is negative 4 times current 2, and negative times negative, that's positive 4 times current 3. Then combine like terms and arrange. So starts with the current 2. So this is negative 4 times current 2. And this 6 plus 4. So this is positive 10 times current 3. So these are the two equations we're going to use to solve for the current 1, current 2, and current 3. So from these three equations, so observe in the equation number 1 and equation number 3, there is common the current 2. So therefore, in equation number 1, we need to solve for current 1, and in equation number 3, we can solve current 3. So from equation number 1 to solve for current 1, so transpose this current 2 to the other side. So this becomes positive. Then divide both sides or divide every terms by 8. So current 1 equals this 15 divided by 8. So we have 15 divided by 8. That's 1.875. Then plus 5 divided by 8. So 5 divided by 8. That's 0.625 times current 2. So this is for current 1. Then from this equation number 3 to solve for current 3, so transpose this current 2 to the other side. So this becomes positive. Then to solve for current 3, divide both sides or every terms by 10. So we have now current 3 equals 12 divided by 10, that's 1.2. And 4 divided by 10, that's 0.4 times current 2. So we have now the value for current 1 and current 3. So we can solve now for current 2 from equation number 2. So just substitute the current 1 and current 3. So from this equation, from equation number 2, so this becomes current 1 is this value. So we have negative 5 times the value for current 1, then plus 18 times current 2, and current 3, this value. So negative 4 times the value for current 3. Then to simplify, so this negative 5 times 1.875. So we have negative 5 times 1.875. So this is negative 9.375. And this negative 5 times 0.625. So negative 5 times 0.625. So this is negative 3.125 times current 2. Then bring down this 18 times current 2. Then distribute this negative 4. So this is negative 4.8. And negative 4 times 0.4. So this is negative 1.6 times current 2. Then we can combine now like terms. So this negative 9.375 and negative 4.8. So negative 9.375 then minus 4.8. So this is negative 14.175. Then for current 2, so combine these three terms. So we have negative 3.125, then plus 18, then minus 1.6. So this is positive 13.275. Then to solve for current 2, so transpose this to the other side. So this becomes positive and divide every terms by 13.275. So divide by 13.275. So therefore, current 2 equals, so to solve now for current 2, so we have 14.175, then divide by 13.275. So we have 1.07. So for current 2, that's 1.07 amps. Then this time, we can solve now for current 1 from this equation. To solve for current 1, then substitute now the value for current 2. Since current 2 is 1.07, so to find now or to solve now for current 1, so we have 0.625, then times this 1.07 equals then plus this 1.875. So for current 1, that's 2.54 amps. Then to solve now for current 3, using this equation for current 3, then substitute now the value for current 2, that's 1.07. So current 3 equals, so we have 0.4 then times 1.07 equals then plus 1.2. So for current 3, that's 1.63 amps.